Kirkwood Math. All right, ladies and gentlemen, here we are reviewing our Unit 1 review for our test. I'm going to go over each problem so that you can study them and have a better understanding of what to do for your test or your retake. The first one here we're going to look at is Alessandra. Alessandra has a special deck of cards. Each card has a different integer on it. The cards are -1, -3, 5, 7, and -8. And we want to know how many of these cards have a value that is less than -4. So there's two things you kind of need to know in this problem. You need to know what an integer is. And then, of course, you need to know what less than -4 would be. Okay, so the first thing that we're going to do is go over an integer. So an integer is a positive or negative whole number. So we're thinking whole numbers and their opposites, okay? Integers. I'm going to type that out for you. So here you can see this. I'd write this down if you don't remember what an integer is. So you've got your whole numbers and their opposites. That includes positive and negative whole numbers. So here are some examples like 4 and -4, 5 and -5. 1 and -1. So all of the numbers listed here are integers, so we actually don't need to worry about that right now. What we need to do is make sure we know what numbers are less than -4. So in order to do that, I'm going to draw a number line. We're going to draw it over here. Maybe if it's working. Why are you not working? Oop. Hold on. All right, here we go. So here I have a little number line. I have marked 0 and I've got two sides. Hopefully you remember that to the right of 0 are all of our positive numbers and to the left of 0 are all of our negative numbers. If I start going by integers, to the left of 0, I'm going to start with -1, then -2, then -3, then -4. So remember, it kind of makes a mirror, right? Positive numbers go 1, 2, 3, 4 to the right. Negative numbers go 1, 2, 3, 4 to the left. Okay, so what that means is -4 is pretty small, and so numbers that would be less than -4 need to be a number, a numeral that is larger than 4 but negative. So we already know it can't be 5 and it can't be 7 because they're positive. Okay, and we can see right here that -1 and -3 are to the right of -4 on a number line. So instead, we need to look for something that would go to the left. So it can't be this one and it can't be that one. So it has to be -8. Now, you may look down here and go, well, there's no -8 because the question is saying how many of these cards. Only one of the cards above is less than -4. And don't be afraid, guys, to draw number lines on your scratch paper. A number line is a really helpful visual tool when dealing with integers and rational numbers. It's okay to draw a number line to get an idea of what's going on. All right, number 2. Which set of rational numbers is correctly ordered from least to greatest? All right, so there's two things we need to know here. So we need to know how do decimals compare? Like, how do I know which decimal is larger or smaller than another? And again, we need to know about negatives. We want to go least to greatest, so we're looking for the smallest number first. So remember, smaller numbers are further to the left on the number line, right? The further to the left, the smaller it is. So we are looking for numbers that would fall further left on the number line. And again, notice that as I move left, the digits, okay, the numerals of my negatives become bigger. So a bigger negative actually has a smaller value. So that's why up here I wrote the larger the negative, the smaller the value. That's what you need to remember. So over here in our multiple choice, we want to make sure that we're looking for really big negatives first. Those are going to be smallest. And then smaller negatives means it's a bigger number. Then we have to remember how to compare digits or decimals. The way that we're going to compare decimals is we're going to look at place value. So you're going to look, 'cause right now we have all zeros. So the first thing we're going to do is look at the tenths place. Those are 5s. Then the next thing you're going to do is look at the hundredths place. In the hundredths place, you can see that they're all 5s except for this guy right here, which means that he is smaller than all the other numbers. And remember, smaller negatives are actually larger numbers because they're closer to 0. So we're going to go ahead and say this guy right here should be at the end. So we know it is not D, that it has to be one of these two that has the 505 ten thousandths, negative 505 ten thousandths at the end, because that's going to be a bigger number. Okay, then the last thing you're going to start comparing are those final place values right here. And again, when you're comparing in a row, we're looking, that's a 1, a 0, and a 5. Okay, so we're going to go kind of backwards from what we usually would. We actually want it to be 0 through the biggest number down here. And so the one that does that is this guy right here. So the answer is C. All right, on to number 3. Tamara wants to select a negative integer that is closer to 0 than -3 on the number line. So again, our number line is going to come in handy here because we want something. Here's -3 and here's 0. We want a number that is closer to 0 than -3 on a number line. So I want something between -3 and 0, and we want to know how many possible choices does she have? How many numbers are between -3 and 0 on a number line? Okay, and if you take a look at this, you can see that there are 2 numbers here, -2 and -1. Those are closer to 0 on the number line than -3. So our answers would be B. Okay, we've got 2 choices there. All right, number 4, we're looking at a table of points, and we need to match it to a number line that has these points placed correctly. Which number line shows the correct placements of the points listed in the table? Okay, so if I'm looking in here, I'm going to look at the easiest ones first. So we have a point that's on -0.73. So let's go ahead and take, this is -0.73. That should be right here. Okay. And so the only number lines that have point B placed in that spot are A or D. So we're going to say automatically that it's either A or D. Okay. Whoops. The next one that we can use to compare would be something else that's pretty easy. So -731, that's going to be pretty close to -7.3. So we know that A should be really close to B. So here they have A pretty far away, and here they're pretty close. Let's check another one. C is going to be pretty large here. 733, so it's going to be just next to A. Okay, they're both kind of next to A. And then D is going to be actually even closer. Oh, 5.5. That would be between the two. 73.5 is going to be in between here, so that's going to have the D. So that's going to be in between the -73 hundredths and the -74 hundredths will be -0.735, if I can write it. That would be right here. So D is our correct answer on this one. Okay, for number 5, we need to place these rational numbers in order from least to greatest. So we know they're rational numbers because they are all fractions or decimals, which can be written in the form A over B. And we need to put them from greatest to least. So again, remember our negatives, a bigger the negative, the smaller it is. So we want small negatives first to big negatives, okay? Now we've got fractions and decimals and all sorts of numbers here. So we want to do either change them all to the same type and change them all to fractions or all to decimals, or we need to do a combination of both. So I'm going to place a number line We're going to do some changing of numbers, and we're going to place them so that we can figure out which one's the greatest and which ones are the least. Okay, so because the numbers that they're using are kind of difficult numbers to work with, I probably wouldn't change these all to fractions. 61 hundredths is not going to reduce, and making it even larger is just going to be more complicated. So what I would probably try to do is change them to decimals. Now, if you know your long division and you can do it with a decimal point, then all you do is divide your numerator by your denominator. So the top goes inside the box and the bottom goes outside. You put a decimal point, bring it up, and then add a 0. And then from there on, you can start dividing. But not all of us are to this point yet. And to be honest, dividing with decimals is a 6th grade standard. So if you are not here, this is what I recommend. So I made a number line. I marked where -5/10 would be. I can place these two decimals easily on this number line in an approximate location. So if this is -0.5, then -0.6 would be about here, which would place my points about here and here. So that's going to be these two decimals here. Okay, so the 6-1 is on the left and the 5-9 is on the right. Then if I'm going to go and place my next points, what I did was I divided my number line into 8 equal pieces on top in blue, and I'm going to find 5 of them. So we're going to count to 5. 1, 2, 3, 4, 5. So this, 5. This was a piece. 1, 2, 3, 4, 5 right here. So this would be -5/8. Okay, and you can see that it's further left than -61 hundredths. Then I'm going to take another color and I'm going to do -4/7. On the bottom, again, I just kind of roughly divided my number line into 7 equal pieces, and I'm going to count 4 of them. 1, 2, 3, 4. And that is going to be larger. It's closer to 0, farther right, than the -59 hundredths. So in order to go greatest to least, we are going to have to look this way, okay? Because the larger numbers are farther to the right. So my -4/7 should be first, so I know it's not A or B. The next one should be -59 hundredths, which makes my answer D. So you can convert them to decimals by dividing, but if you're not there yet, divide that number line into equal chunks and count. This next one is pretty straightforward. You need to find the ones that are done correctly and how many points that Martina is going to get. All you have to do is check all of her inequalities and see which ones are right. You can use a number line to help you. Just remember, the larger the negative, the smaller the value. All right, so I went ahead and highlighted the ones of Martina's that are correct. These here, you've got some positive numbers that are said to be less than negatives. That's not true. And then you need to remember that 1 is larger than 0, and that the smaller the negative, the larger the value. So that one is wrong. All right, on number 7, Kevin lists all of the integers with absolute values less than 2, and Bria lists all of the integers with absolute values less than 4. We want to know how many more integers are on Bria's list than on Kevin's list. So remember, absolute value is its distance from 0. Absolute value is always positive. So whatever number I put in this absolute value sign, the answer is always going to be positive. So the absolute value of 2 is 2, and 2 is not less than 2, so that one can't be right. So we just have to think of all the numbers that we can put into the absolute value sign that will make the equation true. Okay, so 1, the absolute value of 1 is 1, the absolute value of -1 is 1, and the absolute value of 0 is 0. Those are all less than 2. And then for Bria, you've got all of the ones from above, but we can also do 2 and -2 and 3 and -3. So the difference between them would be 4 numbers. All right, join me for part 2.